Hello there, this is Daniele from Toolchefs and welcome to the final video of the Locomotion series. In this video we're going to have a look at the changes that we have done to the Behaviour modules so that they can interact with the Locomotion system. I've prepared this simple scene with a grid layout and a Locomotion module which is using the Locomotion system that we have created earlier. If I press play, the agent is just playing the idle clip because we're basically not changing the target linear velocity or the target angular velocity. So for this example, I'm going to use the follow target module. I'm going to change the goal to be 500 here. So it's basically just in front of the agent, so probably around here. And if I press play, we see the agent jogging until he reaches the target. Here we find also this new section, the Locomotion section. You will find the same attributes in other Behaviour modules, not all of them, but some of them, like for instance the follow mesh. Basically with the follow target here you can both edit the linear velocity but also the angular velocity. So if I uncheck this, the agent will go back to the idle clip. I'm just gonna activate it. Here we can provide a maximum for the linear velocity. So 300 is the value for the jog, so I'm actually gonna set it to 130, which is the walk. So now the agent is just walking towards the goal, and then it stops. You can of course change the fall-off radius. This basically is the distance where the agent is closer than this distance to the target. Then the target linear velocity is blended towards reaching the minimum value of that you have provided here. So if I press play, we'll see the agents basically having a smoother transition while reaching the goal. A good practice is also changing the target distance to be the same of the target radius here. This is not mandatory, but again, I mean, it's a good practice. And if you want, again, you can also uncheck the angular velocity if you don't want to affect the angular velocity. In this example in particular, doesn't make much of a difference just because the agent is just walking straight. Okay, now let's have a look at another example. Here I've prepared a scene with an agent group. So we have a grid layout, a Locomotion module reading the Locomotion asset that we have created earlier, a follow curve module which is using this curve here. And then we also have this add metadata module, which is setting the target linear velocity to 130, so the agents are working. I'm going to select one of the agents, so maybe this one. And for the Locomotion module, I'm going to activate the debug so we can see the clips that are being played and their weight. So for instance, here at the beginning, we see that the man walk left 45 is being played with the man walk. And the man walk has a higher weight, and while the simulation runs, we'll see other clips being played, like for instance here we have the man walk right, and again the weights changed during the simulation. So let me clear the selection and also deactivate the debug. One thing to know is that the follow curve doesn't have the same attributes as the follow target, as we mentioned earlier. Not all the modules have the same attributes, and this is because the follow curve doesn't really affect the linear velocity of the agents, but just the angular velocity. And you can even prevent that from happening by unchecking this checkbox here. So here we said that we are changing, so we're setting the target linear velocity with this add metadata module, but you could even use an area trigger to change that metadata while the simulation is playing. So for instance, in this case, we have attached this plane to the area trigger, and we are saying change the target linear velocity to 300, and then use this blending as basically this number of frames for blending the values. Okay, so if I press play now, the agents should start jogging when they enter the area trigger. Okay, now another example. I've prepared a scene with a mesh cutter layout. So we have the basically agents being created on the vertex of this plane here. And then we have this Locomotion module, which is reading the Locomotion asset that we created earlier. Here I've animated the plane so that the plane moves, and we would like the agents to follow the plane. So what we can do is add a follow mesh module. Then I'm going to middle mouse click the plane and drag and drop it on the mesh attribute here so that it's connected. Now I'm gonna press play, and I'm gonna see the agents following the plane. We might see some weird artifacts, especially when the agents stop later. Yeah, so you see here, we would like the agents to stop instead of keep moving. So one thing what we can do is, like, we can say, we can change the minimum distance to 10, which basically is telling atoms to ignore the agents if they're closer than 10 units to their vertex, so the vertex associated with on the plane. And also I can change the locomotion target distance to be maybe higher than that value, so maybe 15. Whenever the agents are closer than 15 units, we're just going to use the minimum linear velocity. So they're just going to basically just be in idle. So if I press play now, let's see if this works better. Yeah, so this is better than before. Okay, so now let's have a look at another example. Another important feature with the locomotion asset is that it can be used within a state machine. So if we go in the Atoms UI, go in the state machines tab, let's create a new state machine here. Let's go with just state machine like this. You can create a new state, actually create a couple. So this one is going to be the idle. I'm going to set them an idle here. Then this one is going to be the walk. And I'm going to assign the walk. Man walk, yeah, like this. And then finally we can also assign locomotion. So I'm going to say I can go from idle to walk and vice versa, and like this. Sorry, the other way around. And here I can assign my locomotion here. And here, as you can see, we can provide the maximal acceleration and the average num frames for that we can also assign on the locomotion module. So here, the first value is the linear average num frames, and the second value is the angular average num frames, and the same thing applies to the maximal acceleration. So this is the linear one, and this is the angular one. So I'm gonna register this stuff here. And now basically we can use this state machine. So I'm gonna assign it to my man, just put this video here. I'm gonna save this one. Now I'm gonna rewind, and I'm going to set the state machine. So now we are playing the idle clip because we're in state 0, and if you remember, the state 0 is this one. If we use state 1, we're actually going to be walking like this. And if we use state 2, we're going to be playing the locomotion state. And because the target linear velocity is 0, that's what basically the idle is going to be. We're going to play the idle clip. So what we can do is, like, we can add a metadata, for instance. Metadata, and say I want to change the target linear velocity. This is going to be a double, and say I want this to be 130, and now we're going to walk. So what we can do here is we can, you know, using the state machine, we can go from a state to another, even if it's a locomotion state. So we can say I want to start walking. So this is going to be the walk. I'm going to set a keyframe here. I'm gonna set another keyframe here, and then we're gonna say I want to go in the locomotion state. Then down here, what we can say is, like, I want to go from the locomotion state to the idle. And maybe we can even say for the target linear velocity, we can say I want to set a keyframe here because I want it, like, to be in idle when I switch state. And that basically, in this way, we are gonna we're gonna set the target linear velocity to 0 before it actually before we change state from the locomotion state to the idle. So if I press play, let's see if these keyframes make any sense. yeah, it's kind of working. I would like to show you the debugger because it's gonna help you more with the locomotion and whenever you're using it in a state machine. So let me press play. So now we are in the work. Now you see we're going to the locomotion. Now when we are in the locomotion state, we see even these the locomotion graph here being displayed, so we can see what actually we're playing. And of course, because the target linear velocity now is 130, we're just playing the work. But now we should see that changing, the green circle moving towards the main idle loco clip, and that's what we're playing now before we actually transition and go to the idle state. And now we're in the idle state. So this is just a quick example showing you how you can actually use a locomotion asset within a state machine. And now let's have a look at another example. Okay, and finally, let's have a look at how we can use a behavior tree to interact with the locomotion. So here I've prepared a scene with 5 agents. They are playing this locomotion asset that we prepared earlier. I'm setting the target linear velocity to 130, so they're walking. And then I'm also adding this new metadata called status, and I'm setting the default value to 0. I'm also setting the metadata, this metadata to 0 only when the agents are getting created. So let's start by creating a new behavior tree. Let's call it back and forth, like this. So first thing, we're going to create a repeat node, repeat forever, then an optional. So basically with these two, we make sure that we never get out of the behavior tree. Actually, before making the network, let's actually create the metadata that we're gonna need. So for sure, we're gonna need that status metadata that we saw earlier, and it's gonna be linked. Then we're gonna need for sure the position, and so this is gonna be a vector 3, and this is link as well. We need the direction. So all of this stuff we're gonna modify later, or we need to have the access to these values later. So I'm just gonna create them straight away. Then we need the mesh, the 2 meshes, because we in this scene basically what we want to do is like we want to make sure that the agents, as soon as they enter this plane, they turn 180 degrees, and then they do the same with this other plane. Okay, so mesh 1, this is gonna be a mesh, and this is gonna be exposed. I'm gonna create a mesh 2, and this is gonna be another mesh, and this is also gonna be exposed. And then we're gonna have a mesh translation, and this is gonna be a vector 3, and this is also gonna be exposed. Mesh translation 1, this is gonna be exposed. Wait, where's the mesh translation 2? Sorry about that. Okay, now we make the mesh scale, vector 3, sorry, exposed, and then we make the last one, again another mesh scale, vector 3, and it's gonna be exposed. So vectors, yeah, this should be okay. Okay, so let's go ahead with the tree. So we're gonna first build a make a selector. Then we're gonna have two branches, one for each plane. So we're gonna say conditional if the status is not. So we're gonna invert this one. We're gonna say int. It's gonna be my key. So status is not equal to 2. Then what we want to do is we want to make sure if that is inside the area. So inside this plane, the position is going to be my position. So this is the position of the agent. And we are checking if, no, sorry, no, wrong one. Let me actually do this scale. Scale, mesh translation. Okay. Cool. Then we set a backport key, backport entry, and this is gonna be status. Let me, what is it here? It's an int, and we set it to 2. So basically, once we enter this area, we made sure that before the status wasn't 2. Now we set it to 2, so basically we're not gonna come back in here. Then we say we need to set an agent metadata, which is going to be the target angular velocity to 180. So we have like a 180 degrees. Sorry, I forgot to add like a sequence here because I need to run all of these nodes. So that's gonna go there. This one is gonna go here. And then we need to scale the direction. So it's gonna be direction. This is also gonna be direction. It's gonna be -1. So basically we're flipping the direction in this way. Then we're gonna wait for a frame. And then we're setting again the angular velocity to 0. This is because we don't want to apply a 180 degree rotation to our agent at every frame. We just want to do it at one frame so that we can run that unsynced clip and then go back to just playing the walk. And now I'm gonna copy paste this stuff here. And here we're gonna have just different values for the status. So it's gonna be 1 and 1 here. And then of course we need to have the other mesh. So 2, 2, and 2. Everything else should be okay. So let's see status 1. Yeah. Direction, weight, and yeah, okay. So if I save this one, close it, come back here to behavior 3 and assign that. I'm going to drag and middle mouse button and drag and drop the two planes here. Then I'm also going to connect the scale and translations. So let's see if I can find them quickly. Yeah, scale 1, translate 1, plane, this is scale and translation. Okay, so if now I press play, let's see if this works. Yes. Okay, this is cool. So basically, this is just a quick example about how you can use a Behaviour tree to interact with the Locomotion system. Okay, so this is all for this video and thanks for watching.